In a game, moving a unit is supposed to be the hello world of features. You click here, the little guys go there. Simple, right? Welcome back to the channel and today's topic pathfinding. Well, in procedural generation, where nothing is simple and everything wants to kill your frame rate, I'm building a game where I need to move hundreds of units across the map. Today, I'm going to show you how I built the pathfinding pipeline from the mouse click to the NavMesh. But let's start at the beginning. We go from the click to the command, we check the right algorithm, and then we discuss NavMesh and raycast. First things first, we need to translate the player's intent from the flat 2D screen into a deep 3D world. When you left-click, I cast a ray from the camera into the scene. If that ray hits a unit directly, boom, selected. The calculation is done directly by the JMonkey engine, and I'm just using the result to mark the selected unit. But let's be honest, trying to click on a tiny 1-meter rock from 50 meters away is a nightmare. You're going to miss. So I added a fat finger fallback. If your ray misses the unit and hits the ground instead, the code doesn't give up. It effectively draws a circle around that ground point and asks, okay, did you mean this guy? This makes selecting small units or items feel snappy and forgiving, even if your aim isn't perfect. Selecting units is something the player is doing all the time, so this should feel really good. For selecting groups, we do something different. Casting a ray for every single pixel inside the selection box would melt the CPU. Instead of checking if the box touches the units, I check if the unit touches the box. So I take the 3D position of every unit on the screen, project it mathematically into 2D coordinates and check, is this dot inside the rectangle? Simple, fast, and hopefully scalable to thousands of units. Once we have the selection, the right click is the action. This raycast ignores units and looks strictly for the terrain and calculates the exact coordinates. Okay, the game now knows where we want to go. Now, how do we get there? If you took a computer science class, you know the answer. A star. This is the golden child of pathfinding. It's reliable, it's accurate, and it finds the shortest path. My terrain is technically a giant grid of high values. A star loves grids. It checks neighbors, calculates costs, and finds the perfect path. But for units, it might not be the best solution. It sometimes looks really robotic, so unit can only move horizontal, vertical, diagonal. They look like rocks on a chessboard. And it's slow. On a 2000 times 2000 meter map, that is 4 million nodes. Asking the CPU to find a path every time you right-click, well, that might be a crime against your processor. We need to start thinking in surfaces. We need a navigation mesh, or short, NavMesh. A NavMesh really simplifies the world. Instead of a million tiny grid squares, an open field becomes just one big polygon. Go from A to B becomes a straight line and not a zigzag calculation. Now, I could have written my own geometric voxelizer, but I also want to finish this game before I retire. So I started to use Raycast4j, the Java port of the industry standard. Raycast does something really cool. It vocalizes the world, turning your 3D geometry into tiny cubes and then melt them down into walkable surfaces. It can handle the real hard stuff for us. Is the slope too steep? Is the water too deep? Is the door frame too short? If the answer is yes, Raycast cuts it out. But here's the first hurdle. Raycast doesn't understand JMonkey Engine's terrain. JMonkey Engine's terrain is a high map, a 2D grid of floats. Raycast expects a triangle mesh, a soup of 3D vertices. So I have to write a translator. I loop through every single pixel of my height map and manually build a 3D mesh out of it. I calculate the vertices and connect them into triangles. Top left, top right. This is where I got clever. I don't just blindly pass everything. Inside this loop, I check the water level. If it's too deep, say more than 20 centimeters of water, I simply don't create a triangle for that spot. I hand Raycast the world with the giant holes where the lakes are. Raycast looks at it and says, well, there's no floor here, so I can't build a NavMesh. Boom. Water collision handled for free. No invisible walls required. Finally, the configuration for Raycast to bake the geometry. I use a cell size of 0.5, so every 0.5 meters it samples the world. Smaller is more accurate, but slower to generate. I use an agent radius of 0.6. This defines how fat your units are. Raycast actually shrinks the walkable area away from walls by this amount, so units don't clip into trees. And I use a max slope of 45 degrees. If a hill is steeper than that, Raycast marks it as unwalkable. And here you see the result. In this debug view, you see the NavMesh, the colorful, simplified polygons laying over the terrain. There was just one problem. Generating a NavMesh for a procedural world is slow. Often Raycast is used to pre-bake the NavMesh, which I can't do here. Generating the map at once during the startup resulted in a 10-minute loading screen.
A few moments later, 2,000 years later, one eternity later.
So we have a target, a command, and after 10 minutes, a perfect map where we can walk. So the next time we will tackle the loading time as well as some other issues. Because if I tell 50 units to go to that rock right now, they won't stand around it. They will all try to stand at the exact same pixel, merging into a singularity. In part 2, we will tackle the crowd system. We will cover steering behavior, collision avoidance, and the multi-threading nightmare requiring to keep that all running. Don't forget to like and subscribe so you don't miss the chaos. See you to the next build.